So here let's go through some different properties of our rational functions. So, and right here it says quadratic, but this is rational. So when I look at this function here, I see we have x in the denominator. So that tells me I want to work with our parent function of 1 over x. But then what we're going to have is a vertical stretch of 2. And then we're going to move right 3, up 1. And what I actually do with rational functions is with the shift, I use that for finding my asymptotes first. So we're going to have a vertical asymptote at positive 3, and we'll have a horizontal asymptote at positive 1. So let me go ahead and draw those in. We'll have a vertical asymptote right here, and a horizontal asymptote right here. And with that, if I was graphing 1 over x, I would have 0, 1, half 2, 2, half. I would have that structure going, but we have a vertical stretch of 2, so what I'm going to do is stretch those points upward by a distance of 2. And what this does is it kind of takes care of the vertical stretch at the same time as the shifting. So with that, I'm just going to be close there and get those points drawn down, and then we approach 0 in the long run. And then over here, same idea, where I would usually have these key points. I'm going to stretch it by 2 vertically, and then kind of use those asymptotes as the barrier for the graph. Get closer to that asymptote as we go there, and we're going to approach 0 in the long run there. So there's my graph. So for domain, we want to skip over positive 3. So we're going to go negative infinity to positive 3, but not include it. Start at 3 and go off to positive infinity. For the range, we're going to do the same thing, but we want to exclude 0 from the y values. So negative infinity up to 0, and then from 0 off to infinity. So there's our domain and range. For this graph, it is not, let's see, if I kind of read along left to right, here we're decreasing, our graph is going downward, and then we're going to have the spot where it's not defined, and then it starts decreasing again. So there's no increasing intervals. And then for decreasing, we want to skip over positive 3, so we're going to go from negative infinity to 3, and it's going to basically be the same as our domain, because we were decreasing everywhere, but everywhere does not include that positive 3 because there's a vertical asymptote there. Okay, let's look at some composite and inverse functions, as well as some AROC and difference quotients. Okay, so I have these two functions. F of x is 1 over x squared, and g of x is 2 over x minus 4. So if I wanted f of g of x, so I'm going to go f of, and g of x is 2 over x minus 4. So f tells me to take 1 over my input squared, and my input's going to be 2 over x minus 4. And we want to simplify this down because this is complex right now. So it's going to be 1 over 2 squared is 4, divided by, I'll leave this factored out, x minus 4 squared. We can simplify that out. To get that out of what we have a denominator within a denominator, I'm going to multiply the numerator and denominator by that x minus 4 squared. So down here we get a nice cancellation, and I'll have this x minus 4 quantity squared up there over 4. And I can leave it like that, or we could expand out the square like this, and that looks great just like that. There wouldn't be anything else we can cancel out because there are no common factors between the numerator and denominator. Okay, let's say we wanted to find the inverse for g of x. So I'm going to go ahead with x equals 2 over y minus 4. I'm going to multiply both sides by y minus 4. Divide by x. and add 4. So my inverse function is going to be 2 over x plus 4. Alrighty. Average rate of change, let me just write down, so g of x is 2 over x minus 4. And we're going to go from 5 to 8. So g of 5 is equal to 2 over 5 minus 4, which is a 2 over 1. G of 8 is a 2 over 8 minus 4, so 2 over 4, 1/2. So let's go g of 8 minus g of 5 over 8 minus 5. So that's going to be a 1/2 minus 2 over 3. And simplifying that down, let's see, a half minus 4/2 is a negative 3/2 over 3. Which that's the same as negative 3/2 times a third. So that'll be a negative 1/2 with those 3's canceling out. You could also think of that as multiplying by 2, multiplying by 2. So you'd have a negative 3 over 6, and that would get you there as well. Okay, last piece is going to be difference quotient with 1 over x squared. So we are going to have 1 over, but instead of x, we'll have x plus h, and we'll have that squared, minus 1 over x squared, all over h. And we want to simplify this until we can get the h to cancel out. So what I'm looking at is I have a complex fraction because of these denominators here. So I want to cancel those out, and to do that, I need to multiply by my least common denominator, which would be x squared times x plus h squared. Altogether, those are my common denominator. And whatever I do in the numerator, I also have to do in the denominator. So what's going to happen is those need to distribute in. I'm going to go ahead and write all of this out. So we'll have that x squared times x plus h squared divided by x plus h squared for that first term, minus x squared times x plus h squared from that multiplication over that denominator of x squared, all over, let's go, h times x squared times x plus h squared. So when we multiply by the least common denominator, we're going to get these nice cancellations out, which is exactly what we want, so that we don't have a complex fraction anymore. So this is going to be x squared minus x plus h squared over hx squared x plus h squared. Now, I can't cancel anything out yet because of that subtraction right there. So what I need to do is expand out this x plus h quantity squared. So it's going to be x squared minus, and I want to think about parentheses here, with x squared plus 2xh plus h squared. And what's going to happen is, and then let me write down that denominator before it disappears by accident. That negative needs to distribute in. So what we're actually going to have is minus x squared minus 2xh minus h squared when I drop those parentheses. So that x squared minus x squared is going to turn into a 0. So I'm left with negative 2xh minus h squared over hx squared x plus h squared. And now I can see that common factor of h where it can cancel out. So we'll have a negative 2x minus 1h over x squared times x plus h squared. And that would be our difference quotient for this one.